Okay, now we are going to move to our next topic, which is nets, area, and volume of solids. What is our interest in there? So what do they need here? Learner meets and draws 2 and 3D shapes and explore their properties. Calculate surface area. The learning how to continue calculating surface area, converting units from one form to another, calculating surface area of 3-dimensional figures, and so on. But you see, those are the learning outcomes. So meaning the question should be able, activities of integration and setting should be able to touch them. Boom. So let us see the activity we have here. It says in your village, a farmer is planning to build a grain storage silo. Silo is like, okay, in primary it's what we call a granary. They used to store food, but now silo is something that is like a tank, very big, where we store food in case we expect some calamities ahead. A silo, cylindrical body with the radius 40 and the height 100 meters. Then at the top, they are putting a hemispherical dome. The cylinder is to be designed to maximize storage capacity, but minimizing the cost. Let us first get the shape of the silo we need. So tell us that it's going to be having cylindrical, something like this. Okay. So this is our cylinder. Show me that that's now our cylinder. Okay, let me do this. I think that's that this cylinder here is having height of 100 meters. Height of 100 meters. Then it's having what? Radius of 40 meters. 40 meters, like that. Then they are going to put a hemispherical dome. Sorry, my dome is dooming. It's not dooming. Let me doom it well. It wasn't dooming properly. So let me doom it well. It's dooming like this. Okay, it's dooming. Of course, for it to fit here, it has to be having the same radius. So that is obvious. They never had to tell you the radius of the dome. So it's still 40 meters for it to fit. By telling us to calculate the surface area of this with excluding the base of the cylinder. What base are you going to exclude? Because we need the space here, so we are not going to include the surface area of this thing here. So we're just going to be having this and then the rest. So now let us start by getting the total surface area. So our total surface area, is going to be the surface area of the cylinder, then plus the surface area of the hemisphere. Hemisphere in that order. Okay. Now our surface area of a cylinder is going to be, remember, to get the surface area of the cylinder, remember we have always our height times 2 of the circumference. So we have it as 2 pi r/h. Then plus the surface area of these 2 circles. But remember, we're not going to have this. We're going to have only this. Because with this one, we need the space here, so we're not having that surface area. So that's why I'm going to just add pi r squared, not 2. Then plus the surface area of the hemisphere. Remember, for a full sphere, the surface area is 4 pi r squared. So hemi is just half of the full sphere. So it's just going to be 2 pi r squared. So just substitute. So this will be now, we have 2 pi, let us take 3.14 times the radius, which is 40, times height, which is 100, then plus times radius, which is 40, squared, plus 2 times 3.14, then times our radius, which is 40 squared. So what do I get there? So I'll get so I'm getting here 440,922 meters squared. So that's the surface area. So we are going to need material of that size. So then they went ahead to tell us our requirements to determine the total volume of the silo. So now our total volume is going to be the volume of the cylinder, plus the volume of the hemisphere. Now our volume of the cylinder for it is pi r squared h plus that of the hemisphere. Remember, for a full sphere is 4/3 pi r cubed. So this one is now going to be a half of it, pi r cubed, which we just substitute here, 3.14. cubed. So then I get my total volume there, which is so the volume I'm getting here is 636,373.3 meters cubed. That will be the volume. Then you can come and respond. Therefore, the total surface area is 40,000. And the total volume of the silo is 6,373.3 cubed. We always give one decimal place in such scenarios. So the only thing we had to learn here is that we are removing one of the surface areas there for this there, then the surface area of the hemisphere. So that's it. For more of these ones, you can always visit the playlist, then you see more about the nets and volumes. That's it. See you.